Here we are looking at a hypothesis test for the population mean using a z-test. So we're looking at the average breaking strength of these cables. So usually they have a mean of 1,950 pounds and a standard deviation of 70. So it's claimed they've made an improvement that has increased the mean. Okay, so that tells us what our alternate hypothesis is right there. We are looking at what the mean is greater than 1950 because they use the word increased. So to evaluate this, we are going to go test 25 new machines. And their mean is found to be 1,989 pounds. So it does look like it's more, but what happens if we go test every single machine? What happens then? So we want to test this at a 0.01 level of significance. All right, so the next thing we need, this is a z-test statistic because we are doing a normally distributed population. So to find the test statistic, we are going to use the formula x bar minus the mean divided by the standard deviation over the square root of n. So our formula is going to be, when we plug these numbers in, it's going to be 1989 minus 1950 divided by standard deviation is 70 over the square root of n. So we tested 25 machines. All right, so this one's actually easy enough. We don't need a calculator. We can do 1989 minus 1950 would be 39. The square root of 25 would be 5. So 70 divided by 5 would be 14. And 39 divided by 14, there's where we can use a calculator, right? But I will show you how to put that all into the calculator also. And we also need to find the p-value using the calculator. So let me jump over to the calculator. All right, 1989 minus 1950 equals 39. Oops. Divided by 70 divided by the square root of 25. So that is our test statistic, 2.7857. So it says to round to at least 3 decimal places, so we can actually make that 2.786. To find the p-value now, we are looking at our normal distribution curve. Okay, so we have the normal distribution. So this is still working under the normal distribution curve like this. We want to know at the 0.01 level of significance, can we support this claim that it has increased? So our test statistic is at 2.78. So that would be down here, 2.786. And we are looking at, has it increased? So we're looking at this area. Okay. So what we want to do to find our p-value is look at the area that is given to us right there in the yellow. So going back to the calculator, we're going to click this button for that area. And we're going to click equal. Okay, so that's a really big area that we have there. But if we go back to that picture, we should see that there's not that much area there. Like it's not going to be 99.7% of the circle carried, okay? That's because the Alex calculator, when it finds it, since it says less than or equal to here, that actually gives us this area. So if this area accounts for 0.997, what we actually have to do is 1 minus 0.997 to get our area of the yellow. So we can come back over here and we can go to, let's store that, 1 minus the stored number. We hit recall. And we should get our p-value right there, which is 0.00267. Put some extra decimals in there because it's small. Last thing here is, do we support the claim or not? So our rule here is, if we're talking about the p-value, is if the p-value is less than alpha, we are going to reject the null hypothesis, which means there is evidence to support the alternate hypothesis. So I'm just going to write yes there. If the p-value is greater than alpha, we're going to, let's say, do not reject. So we do not rejecting the null hypothesis. That means there is not evidence to support the alternate hypothesis. So on this one, our level of significance here is our alpha. So that is our alpha. So our alpha is 0.01, and our p-value is 0.00267. So this is less than 0.01. When the p-value is less than alpha, we reject the null hypothesis. So we do support the alternate hypothesis. So this is going to be a yes.